Good evening. Welcome back to Brutality on Venus. It's not very brutal anymore, if I'm going to admit. Tonight, I want to work on the auto part of the Auto-Smelter ordering system. So we had started yesterday with getting the silos all fired up, wired up, shooted up, and now I think we're on to labeling and figuring out how I'm going to do that. So, from what I'm thinking is I will have to have a chip there specifically to translate the amount that's in the silo to the memory chips. So, we got a storm coming in. Must have just kicked up. Yeah, look at that. 752 seconds. It's the biggest warning I've ever gotten. Orbiting oxygens, space savvy solutions, galactic gravels. Unfortunately, not what we're looking for. Now, I can, just by looking in my bag, I can see that I need more cable. Yes, thank you. That's exactly what I was thinking. So, past me was thinking of now me. And, yeah, got all this going. And what's really interesting is, did I really fart around that much after I placed the orders? I didn't think I did, but maybe I did. Well, anyway, here's some chutes. Got lots of chutes. Don't have any ladders, though. So, anyway, what I was thinking is, might be worthwhile to fire this up and get a basic programming. So this is going to be, this is the translator for each thing. So we're going to have, probably putting this in the stack would be the best way to go about it. So this is possibly also going to control the loaders, sorters. Okay, so we're going to define hash stacker 1. This is actually probably unnecessary. Yeah, I will need the sorter. Will definitely be used. Sorter. Or will it? Let me think about this. Clear database, or clear the stack from our current item. Let's go ahead and put db, address 0. And I'm forcing this instead of doing a push because I don't know what it does with a stack pointer, and I need these at least relatively sensible areas. So first off, we're going to hash. Let's go ahead and get our ingot list. Silver. We're just going to, you know what? Let's go from the top. Let's go from the top. So put astroloy here. Not 0. Actually, should I? I guess it doesn't really matter, does it? Doesn't really matter the order of these. Hastaloy. Put db2 hash. So we're going to list these all out, and we will use the stack to iterate through all of these. Stellite. Go ahead and grab the waspaloy, go to the next one. Constantan. Electron. So this is not the one doing the ordering. This is what's going to be on the backside of the finished product silos. Oh. Huh. I'll have to think about the ramifications of this. So when our production machines actually request a ingot of sorts, they're going to have to come from here. So there will probably be another chip used as a buffer chip in between networks. Haha, sheesh. Okay, gold. I'm just going down the list. Iron. I'm not going to have a lead ingot one because I don't believe that it is necessary. However, I do have enough silos that I can real easily just throw it in there. And maybe I'll just do it to do it, but I don't really want to do that with the lead. Okay, silicon, silver. Okay, yeah, this is 6. Yep, got it. I got it. Okay, so this is all the stuff that we are going to track. Now, initialization. I mean, that's already really initialization there. But we're going to set batch, and this, maybe we're fine with this. Stacker A and stacker B. Setting 500. And stacker reversed. Click on the same one, why don't you? So that will reverse, or all those will be set. Now, I need to set all the silos on as well. I think that's fair. So our stackers are set. They're not necessarily on. Actually, maybe they should be on. That'll turn them on just in case there's any backup or something. It'll make its way through. And now for the next thing, we're going to want to we have to name everything before we turn this on. But what we're going to do, move index SP 0. So we'll go up to the very, very tippy top. We're going to alias ISP as R15. No, R0 alias. Let's see. Reference 1, because I think we're going to need that. I don't know if we're going to really need anything else. Stack pointer of 0. We are going to load, let's see, init stackers. Okay, so we're going to load batch by name. Nope, hang on. Device, let's see, alias dev name hash. Right? So first we're going to get into dev name hash. Device is going to be DB, address is going to be stack pointer. So now we have the stack pointer, we now have the name hash. We load batch by name into device reference. This is going to be device hash. This will be by sorter, the logic sorter type. Name hash is going to be dev name hash. Reference ID, batch mode, average doesn't matter, it should only have one. Okay, assuming, well, hang on. Branch equals 0. If name hash is equal to 0, then we're going to go ahead and jump to main. Or, you know what, we could actually do that right here too. So that will cover both. That will cover both. So at this point we have a device reference, clear D, and this will be the device reference. So we're going to clear the stack. And now these we're going to shift left and. So shift left, prefab hash equals. That's going to be pass. So shift left arithmetically, we'll just make it R15. We are going to shift the name hash, because that's what we're sorting by. We're going to shift that 8, and we're going to OR R15 by R15 OR this instruction. That'll add it to it. I could also do add technically, but I'm just going to do this bitwise. So now we have that, and we can put D, put into device reference. Address 0, R15. So that'll load those up. Set batch by name, dev ref. Hang on. This right here. Actually, set batch. Can I? Oh, yeah. Very nice. Look at that. I can use the reference. Logic type on and 1. Yeah, I think that's fine. Now we will add to stack pointer +1 and jump back to init stackers. So that'll initialize, it should say sorters. Should be sorters. If we want the documentation to speak for itself. So there we go. We will now initialize the sorters with their filters based on their name in this list. So they will pass it. That should work. So that'll initialize it. That'll set these up. And what we're going to do here is trying to think of I think I can load batch slot with a timeout. Load batch slot. Oh, cool. So here's what I wanted to do also. So I wanted to look at the import quantity, import 0. So into R15, device hash is going to be the structure logic sorter. And slot index is 0. And occupied quantity sum. Let me alias timer. Okay, so we'll do a countdown timer. Set. Well, actually, we can just do a select right on this. Select into R14 based on R15. A is non-zero. We want this number. Otherwise, we want timer. And this is timer. So if this is greater than whatever, we're going to have 10 ticks. 10 ticks might be fine. You know what? I'll make it 20. I'll make it 20. Just so things happen. So that should be 10 seconds. So that'll work. And we'll subtract timer. Will be timer -1. Now the idea of here is set greater than 0 on. So in this case, we got the quantity. Don't think we need. We'll write this for now. Set greater than R15 if timer is greater than 0. If timer is equal to 0 or less than 0, then it doesn't matter. We could even do this here and boom, it's all nice and quiet. And then we set batch. This is our stacker and stacker reverse. There we go. So as long as we're passing stuff through the sorters, they turn the stackers on, otherwise they shut them off. That'll save a little bit of power. This number let's go ahead and move ISP to 0. So at this point do I do it from within the loop or do I make a subroutine? I don't think a subroutine really matters. Yeah, so okay, so at this point then this is going to be read silos. So we're going to go load batch and then device reference, and this is going to be hash, is going to be based on the silo. So we're going to read the silo. Name hash is, hey, guess what we're going to need to do here? We're going to need to get the name hash loaded up. Okay. device name hash, logic type, reference ID, and average sum, doesn't matter. So we got this. The idea here is branch equal to 0, dev ref will jump back to main. Otherwise we'll jump back to read silos, right? Yeah, that makes sense to me. So in this case, before I forget, add to the stack pointer 1. Branch equal to 0. Okay, so we have our device reference, we have our name hash at this point. So we're going to load batch. Actually, we could load R15 with our device reference and quantity. There we go. I don't even need to do a load batch for this. Maybe that'll help speed things up. I don't know. But we will set batch by name. Device hash is going to be the device name hash, and the name hash, hang on. The device hash is going to be the memory chip. The logic memory with the associated name. Device name hash setting is going to be R15. So we load the quantity into that chip, and that way an external device using that as a buffer can read how much is in that silo. Perfect. And we go to the next one, and we branch through real fast until we get all of them. So this will handle our stackers. This will read the quantities. Make sure it's stackers. Yep. Okay. Sorters will be initialized. Okay. I don't know if there's anything else I need to go on with this chip. But as it stands, this chip right here is the one that we need for getting those silos loaded. So at this point, do I have another chip just laying there? I do not. Maybe I should print one of those off. I'm going to need a couple at some point, so maybe I'll just print off 2. That meets electrum, I know. Steel, gold. Gold, solder, there's the solder. Okay, that'll make us the 2 chips that we requested. Let's go check the trader. Alloys Build Incorporated. Nope. Unfortunately, it's not going to be too long, and we're going to be... Yeah. We're going to have to build a thing. Build an auto trader. Oh, wait, I pulled one down. I don't remember pulling this guy down, if I'm being honest. Okay. Alright, so we've got our... How are you guys doing? Any more bags over here? We all unloaded. We still got more bags over here to... Cool. Alright, so we need to go through and make sure that we have steel. Steel ingot. So let's go ahead and grab this. I'm going to name you your steel ingot. Your steel ingot. Your steel ingot. Your steel ingot. So we have all the steel ingots. Okay, that's the most important one. Now we'll go just for the heck of it. Actually, do I have... Iron ingot. Iron ingot. Iron ingot. Have I gone through copper? Copper. Okay, it looks like silicon, silver, nickel, steel. Okay. Alright, so I've got the basic ones down. So we've got steel, iron. Let's go ahead and grab copper. Okay. Gold. Doesn't really matter the order. No, not the... Nah. Okay, we got steel, iron, copper, gold. Nickel. Got the nickel, got the silver. Okay. Alright. Let's do astroloy. We'll make you astroloy. And yeah, first one. Okay, that's astroloy. And now we'll go on to hastelloy. Okay, after hastelloy we go inconel. Okay, there's that one. Inconel. Next up, stellite. Okay. I realize that these are all backwards, but that's okay. Aspaloy. Aspaloy. Okay. Constantan. Aspaloy, Constantan. Feel like I'm mixing a couple chips here. Not gonna lie. $16, right? Huh. Okay. Invar. Okay, then solder. Okay, so I'm missing one chip. I'm missing one chip. Okay. Alright, that's a little bit better than I thought. Okay, there's that. Got all our chips in. Okay. Looks like this whole network is set up, ready to go. Okay. Okay, astraloy, hastaloy, iron, inconel, copper, stellite, gold, waspaloy, silicon, constantan, silver, unnamed, nickel, unnamed, steel, invar. Didn't I? Did I not? Okay. So, yes, one more memory chip. One more memory chip, and that'll be good. Let's see, for... okay, we'll put that in there. We won't run it, but it'll be in there. We need more... another memory chip. But I think everything else is hooked up there. Oh, shortest shoots. Shoots. Okay, so we'll do that, and we'll do that. Okay. Go over 2. Just go down over 1. Go down. So that's a 5. And then we go down, and that's a 3. And then we do a fall in the hole. It's a... come on. It's not rocket science. There we go. Okay, looks like everybody's hooked up as they should be. Let's verify that. Nothing looks wonky. Everything looks good. Excellent. Wiring, at least on the preliminary side of things, looks good. Cool. That's excellent. We've got power to it, so we're almost there. So other than one memory chip, so I can label the solder. Well, 2 memory chips, because I've got... hang on. Okay, no, just one memory chip for the solder. One memory chip for the solder. So that'll be good. That'll be good. Oh, AC off. Pipes be singing praises. Still need more Tylenol. So we got our memory chips. Slap one there. One's going with me. That's going to be for the order kit. Memory. And we do have memory. I don't have to print any off. Okay, so that'll get us kind of where we need to go. I have a feeling... I have plastic there. Let's do that. Let's take those with me. And steel sheets. We'll go ahead and take that. I want to go ahead and put a padded wall back in the corner. Let's check our traders again. Interstellar irrigation. That I think we might want to look at. Pay less liquids. Now that one, 30 minutes. We have the opportunity. That's where a big dish would come in really handy. Big dish would come in really handy for that. So, ooh yeah, I'm caught up. All right, so I think maybe we're catching up on that. Come on, come on, interrogate faster. $89, $148. I feel like it's going down a little bit. Ooh, that's actually pretty good. $143. This is... yeah, well, there's one stage up there that's not doing much. I think that's part of my problem. That's where I need the Silenol. And hopefully this guy... contacted. Please land. And this one is... I'm in the 30 minutes, I'm not going to be able to do it. I can just tell you that right now. I should update and put a real satellite dish out there. Just weirdness going on. You're loud, by the way. All right. Pop out. False advertisement. This isn't irrigation. It's so irritating. Well, actually, it's a lot for water. It's like 2 liters each. Carbon dioxide. Huh. I got so excited. I got so excited for that. Let's go ahead and drop one more chip on this side. Magic memory. Yeah, I was really hoping that was actually liquids. That's a bummer. Okay, solder. Solder silo. This will be our solder sorter and our solder stacker. There we go. We got all of our... those are going. Okay, so technically speaking, device not found at line 36. Beautiful. Beautiful. Okay. So line 36, which is clear device reference. Set DB setting dev name hash at this point, right? Let's grab that chip. Grab that chip, export it, try it again. 502. That should be. Should it not be Astroloy? Well, I guess let's start here. Let's start with a stack pointer. Six. Electrum ingot. Okay, yep, true enough. Okay. Now 16. Sixteen is non-existent at this point. Okay, so we'll do that. Branch equals 0. Dev name hash. Let's do that as a secondary check. That feels like a safe call. Bam, bam, bam. Okay. Oh, 59. Line level 59. Okay, well. Whoops. Holy crap. Can I hit possibly any more wrong buttons? So 59, I have a feeling that I need to write this down here. 59 is going to be same story here, but I bet you we should do a branch equals 0, dev name hash main. Let's do that. And I bet all will be well. I need a chip in there to program. Bam. Bam. 1, 16, 1, 11, 16, 11, 16. Okay, so we got 0, 0, 0, 0. Yep, these should all be 0. They should absolutely all be 0.
Hunger caution.
Okay. So, that being said, jump off a building, because that's what I do. We go here and we check that the sorters are all on. Those indeed are on. Okay, and then our 500, 500, 500, 500, 500, 500. So everything is looking good. These are all off as they should be. These are looking really good. So at this point, I don't have anything for lead. So I would have to put in yet another thing. Oh, right, we wanted to drop in a padded window or something. Padded window. This is pretty terrible. Gosh. I feel like that kind of looks like garbage. much, but let's do that. Plastic sheets and glass sheets. There we go. So the one directly back from the purple I can pop. And we should be good. Okay. Yeah, we'll go ahead and put a padded window. There we go. That actually is a terrible idea because of the heat. It is a terrible idea because of the heat. Oh boy. So we have our silos up there reporting to the memory chips of how full they are, which should be 0. Actually, let's put these on because we know how this stuff goes. Okay, that wasn't too bad. Okay. Alright, so now we can bring the... I did that for what reason? I'm not gonna... I'm definitely not gonna be tying the, I am not going to be tying the logic in there. Anything would be over this way. Okay. Alright, so... Oh, right, there's liquid in the pipe already. Which I really don't understand. Okay. Let's go eat, drink, be merry, and think about our next method for the auto. Well, let's check this first. Galactic Gush. Pay less liquids. Okay, so Galactic Gush, that's definitely... I don't think a 5x5 is going to have what we want. However, I'll go for it. The pay less liquids probably would. Probably would. And maybe it's even worth the large satellite dish and all the crap that's needed for it. Steel sheets, heavy cable, plastic sheets. We've got all that. We just need the large satellite dish, which is electronics printer. Electronics printer, Waspaloy, Inconel, Astraloy. We'll try it. Large satellite dish. Uno. Electronics printer. Okay, we want Waspaloy, Inconel. Don't have enough of that. And Astraloy, I think. Yeah. So we don't have... We got enough of that. Do we have Inconel just floating around? I don't think we do. Neither do we have Waspaloy. Okay, well, that was fun. Yep, we're definitely not getting the 6x6 down at the moment. So, eat, drink, be merry, and then, yeah, start on the auto-smelter. Birthday cake. Finish it up. Alright, go in here. Pop that off. Get less stinky. Can't wear your uniform, but you can wear your jetpack. Classic. Okay, there's that. Okay, going on. Onward and upward. Tally-ho! Okay. Oh, I need to check on Larry. I forgot about that. Because he's probably got his hand stuck in the bush. Nope. Larry's not happy. But we're doing good. We're cranking away. We are making progress. So what are we doing here? We're up to 19.1 liters. We have a net positive on the water here. Good. Net positive on the water. We got alcohol. 35 on this side of the radiator. Six in the radiator and 203 over here. And the temperature's falling further and further, so should be no, yeah, look at that. Where's the microcosms of O2 coming from? I don't know. Don't know. One thing I do know is eventually I've got to get the air mix figured out. Okay. Galactic Gush, go ahead and come down. Come down. Okay. We're not quite there. But what we can do is take a review over here. So with the waiter chip, we're going to have a couple things. So what we're going to do, let's do the notepad thing. So we're going to jump through cookbooks stack for finished product. Determine lowest quantity finished product. If reagents available, make that product. Right? And if not, go on to next. Iterate through finished products in tiers. What I mean by that is 1 of everything, then 2 of everything, then 5, 10, whatever. Maybe 1 of everything, then 2 of everything, and then go up to 5 is fine. because what I want to do is make sure that there is one of everything before I make a bunch of stuff. So for instance, steel takes iron as an ingredient, and iron is also a finished product. So if I have, let's say steel is at the top of the list, which actually in the way that I think, I don't know how it's written, it's probably not. We could do with iron. So I could say, go through, see I've got reagents. I can make iron, but I can't make steel because let's say I'm lacking coal. So I could stack all the way up to 10 iron and then starve the steel of the iron. I mean, that's a possibility. So I want to make sure that I've got one of everything before I move on to two of everything. And then from there, I don't know if two is fine, because I'm going to be dropping one of these things out for, you know, production machines, one at a time. So I think two would be fine. Yeah, so that's the thought. And this is going to be reading a memory chip. One moment, I'm going to look outside. That was the forward flanking, is it forward? FFD, forward flanking draft. We definitely have a storm coming in here. So, let me real quick jump into my radar. My special radar. And let me actually bring up the local repeater too, just in case they're running a Skywarn. Okay. My county and the county now are under a severe thunderstorm warning with 3/4 inch hail and 60 mile per hour wind. Good to know. We are under a warning. Okay. So I do apologize. Let me pull up my special radar. And zoom to my location. This may impact my stream. I don't know how network heavy this GIS layered map is. Let's take a look here. We are, what's the timing here? That is 7:30. Oh my gosh, get rid of the overlay. Okay, let me see. Our current time is 9 p.m., so I'll be right at the end there. Do apologize. So I am going to leave the repeater up because we are under a severe thunderstorm. Is it watch or a warning? That's a warning, yeah. Okay. Alright, I'm right here on the map. And yeah, this might get a little dicey. I got some pink reflections that are about to go overhead. So I may actually take a break for severe winters. So, okay, so with that being said, if I disappear off the face of the earth and the stream ends, that's because the power went out. So, I'd like to keep that in mind, and if I need to, I am going to bail out of here for doing the Skywarn stuff, so. Spotter activation may be required. So, actually, that's a pretty cloud formation. I apologize, I'm going to go peek my head out of the window. One moment, please. Okay, I am back. So, the weather is coming in. They are not activating a Skywarn, but they are being ready to, just in case. And all that. So I got the radio on. I wish I had that on a headset, but I don't. So my focus is definitely going to be split here because I actually got some very beautiful sunset-induced rain kind of thing going on here. Nice, almost looks like Venus out my window because it's all red. So, oh yeah, well that's unfortunate. That is unfortunate. I didn't save that, but that's my fault, and I'm okay with that because there's more important things than saving the scratch pad. So. Yeah, so we're going to have to interface those memory chips on this side into this network. And I don't think that's going to take too much because we're almost basically there, but we are going to need to put a padded window on the ceiling up there. So we'll do that real quick. Yeah. Alright. We'll go ahead and talk to these guys. The trader. Water, nitrogen, oxygen, methane, hydrogen, hydrazine, ozone, hydrochloric acid, but no Tylenol. Darn you. I mean, some of this is cool, but I want the Tylenol. Methane filter for 30 bucks. Yeah, I don't know if I want to do that. They want, okay, they want CH402. Whatever. Alright, we'll do that. Jump back up. Jump back up. And over here. So, right here. Where's our... Right here. So... Okay, so we've got 4 sections right here. So this is like the edge. I need to get a good bearing on where this is in relation. We'll do this again. We got all night. Okay. Jump in here. Okay. Twitch notification. Oh, yeah, well, we'll go ahead and do that in the background, and that'll help. Okay. So 1, 2, 3, 4. Ooh, yeah, that's like right there. Okay, so I think that's exactly where the centrifuges are, so maybe... Okay, so the third one. One of those two would be the one to pull in. So that's good, that's good. Let's go out here, turn on our AC. Ooh, this smells like rain. Okay. Doot 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 doot. Whee! Alright. Do this, go over here. So, one of the last two are where we want to be. Okay, so here and here. Now, how do I want to route that cable? That's the tricky part. We could even do it right here and come off the edge. Yeah. There we go. Bam. There we go. There we go. That's weird. There we go. So that one on the end, which is a little bit of a drive, but it's fine. So if I knew it was going to be down there, well, I should have known it was going to be down there. I would have moved these memory chips down that way, but too late now. Although technically, There's nothing to say that I couldn't move the chips as is. It's just another thing to deal with. So this is the data bus. This is what these produce. Or yeah, memory chips, data chips, no power. Let's go. Let's go down like that. So it's going to go through the edge. Okay, there we go. That. Perfect. Perfect, perfect, perfect. Now we can pop that and start the process of getting down in there. Let's do that. Okay. Yeah, very pretty looking out. The pink, the Venusian red / yellow has disappeared. Alright, so we're going to do this, and we pop the one on the end. Oh, right, we need to crowbar that first. There we go. Now we can pull this out with... do that. Bam. Bam. Okay. Okay. So this is our data bus. So this needs to come down here. And we'll do this, and you. Okay, there we go. We now have those memory chips plugged into the bus over here so we can read them. So now, here's where we need to take our notes. So we're going to go ahead and grab this. Go ahead and throw that back out. So the way we have this organized is we've got offset of 0, 1, 2. Okay, so item. And then 1 through 5 are ingredients. And that is okay, yeah, that is item and then quantity. That's 2 bits. 2 bytes rather. And then our offset of 6 here is our furnace, which we don't care about so much for this particular part of the process. And that is pressure. And that is temperature. Okay, and then 9 is reserved. Yeah, because it's just easier to do 10. Yeah, okay, so there we go. So now we have all our offsets there. Very good. So we're going to have a stack pointer. And from there, we're going to probably have a name hash. Item name hash. Not sure if we're going to need a reference ID. Possibly, maybe, I don't know. Let's see, initialization. Is there anything that we really need to do here? I don't believe so. I don't believe so. I think somebody's been eating something chocolate at my computer because there's chocolate in the damn keys. Okay. Main. Alright, so initialization is probably... Alright, so there is one thing we're going to have a requested chip and a shipping chip. Let's see, requested, because it's going to set the requested. And then going to wait for shipping. So we're going to have the requested and shipping chips. So requested mem chip, requested memory chip, and then the shipping mem chip. That's what we're going to have to pay attention to. So in this case, we're going to load batch by name R15 device hash. Now this is going to be, yeah, we're going to do that. Hash is going to be shipping. Setting. I almost feel ref shipping alias ref request. Yeah, we're going to do that. So initialization is going to load batch. Ref shipping is going to be H memory. In that case, yeah, we're going to need to do that. Define H memory. Logic memory. Let's get this going there. I just realized I'm in my spacesuit. I need to get out of my spacesuit, because otherwise I'm going to get filthy. Setting and not setting. We want reference ID. Branch equals 0. Set DB setting 1. Init. Branch equals 0, reference shipping. So if that doesn't exist, we need to go back to normal. Same thing here, except this will be with the request chip, and this is requested. And branch equals 0, reference request, go back to init. But this is also going to set DB setting 2. Hey, thanks for the 1-year mod anniversary. That's amazing. I thought it was like, oh, maybe that was the sub. Wait a minute. I swear. Yeah, maybe that was your subscription. I don't know. But 1-year mod anniversary. Congratulations, Triari. Well done. I appreciate you. Hey, Balin. Thanks for the follow. I actually had a sound effect that was kind of interesting. That's new. Thank you, OBS, for that. That's great. We set the reference for our shipping and request memory chips, because those are vital for the functionality of this. You know what? Maybe I'm going to go ahead and also cookbook. Let's go ahead and assign the cookbook. $11 mod, but also has sub anniversary. Yeah, I'm thinking it's a sub anniversary that I'm remembering, or something, or maybe it's the reverse. Maybe I went to celebrate my mod anniversary on you. I don't know. Uh, cookbook. Cookbook? Cookbook. This is going to be a icy housing. Ooh, these are compact, aren't they? Yeah, that's a different thing. Name hash. Name hash. Name hash. Oh, right. I think that's what I call it. I gotta verify that. That might be IC cookbook. I don't. We'll have to check it out. Logic type is going to be reference ID. I'm one character short. I'm one character short. I might have to do an alias just so I can do that. This is IC-cookbook. Okay. It's gonna IC-cookbook. Yeah, we're gonna run out. So I have to alias this just so I can fit it online. IC-cookbook. Sum is probably fine. Average. We'll do that anyway. Define hash. IC housing hash. Or is that just the whole line there? Yeah, that'll work. 0 for average. Yeah, that's very true. That is very true. That is absolutely true. And I just have a tendency to like to use the text because it's a little bit easier to visually disassemble, reassemble, reverse engineer. There we go. I think I still would have ran out of characters, but yeah. If I need that line back, I'll get it. One way or another. Debug. Yes, debug. Do that. And of course, I do want this. Make sure that I can get it. Otherwise, okay. So I think that's really all I need to do, other than maybe waiting. And I'll do a branch relative for that. Load from, you know, I'm just gonna make the assumption that I'm not gonna pull this chip like an idiot in the middle of an order, and if I do, hopefully I have the brains to get it where it needs to be before. You know what, I feel like I want to try to reclaim that right now. Will it work? Oh my goodness, it'll work just right. I think that's literally character perfect. Character perfect. Nice. Okay, so we have... Okay, so we have this. We have this. You are going to iterate through the cookbook, looking at the memory chip with said name. Okay. We are going to look through here. So we're going to have a stack pointer. Yes. Okay. Main init or start? Maybe I'll do a start here. We'll move stack pointer to 0. Make sure it starts. I don't know if there's anything else I would have to initialize in the loop. Maybe... What are we doing here? I'll worry about the advanced stuff later. First things first, we're going to get from reference cookbook. Nope, get the item hash. So that's going to be what? Item name hash? Item name hash from the cookbook at the address of our stack pointer. Okay. And we go through... How do I want to do this? That is a good question. I want to do a phase? I could do a phase. What's the best way of doing this? So we have our name hash. So we're going to load batch name R15. This is going to be device or the item quantity. Memory chip name hash is going to be item name hash. Setting, and we will do average. So this will get me the number of items that are in said silo. In the silo, which technically average sum. I'm gonna do sum because that would make more sense if I throw another. I could throw more silos in if I really wanted to go overboard on storage. That's scalable that way. Load BN R15. I should probably adjust everything else to use sum too, because there might be a time where I'm dumping multiple silos. That'd be ridiculous, but it's possible. Load batch R15. So this is the quantity. So I've got the quantity for one thing. Is there a min? Oh, there is. Awesome. Okay. Ooh. Hang on. Hang on. Alias number of items. Move. What is the 600, right? 600 is the maximum. Move number of items to 601. Now I don't know if this is ridiculous or not, but we're going to use the minimum. Minimum of num items is going to be either the number of items or the one we just read out of the silo. Now this, I was thinking about setting that to 0 initially, but 0 is always going to be less than any number other than 0. So if I set it to 601, the first silo read will be the absolute minimum, and then we can only go down from there. So that'll get me there. So I think I'm going to have to do this as phases, actually. I'm going to have to do this in phases. Because I want to iterate through there first to get the number of items that are in the silo. Then iterate through and see if it's equal to minimum. Yeah, equal to minimum. So I'm going through the list. The first thing is 0. Then the minimum is 0. If it's equal to 0, make it. If I go through and everything is 1, then the first thing is 1 and make it. If there's oddballs, like I got 3 of 1, 2, whatever, the lowest then is made with priority. So that actually makes sense. So first iteration is going to go through, make sure that's set. So we do that. Right. And then we iterate back through. So let's get let's just get the iterations going through first. Min, num items, there. Then we add to the stack pointer 10 because that's how far apart my recipe is. However, I do need to branch equals 0. Item name hash. So if I've gone past the end of the stack and it is now empty, we need to go back through. In this case, maybe next phase is what I'll call it. Maybe that makes sense. In this case, this is first phase. Branch back to main here. Right? Okay. We do this again. This is next phase. We'll go ahead and we'll put a yield here just to be nice. Stack pointer is set back to 0. We again do this. We get the name hash. And then at this point we're going through to try to find if it's something to make or not. If it's something to make or not. And this is, I think this is the final stage. Because if we're going to make it, we're going to probably jump to a subroutine or something like that. So at this point, then we can jump back to start. I think that'll make a full circle. Okay, so in this case, load batch R15 H memory item name hash setting sum. Set equal. So this is going to be R14. There we go. So R14. If R15 is equal to number of items, make this item. So at this case, in this case, we're going to branch greater than 0, R14. Make item. Otherwise, we are going to add 10 to the stack pointer, and we're going to jump back to next phase. Okay. Perfect. So this will go through and it'll now say we want to make the item, so now we make the item. Or rather, demand the item. So this is where we need to do our thing. So we have the name hash. Ooh, hang on. Let me do a branch AL make item, because we might return, I think. Let's see. So if we want to make the item and it is equal to the minimum number of things, yeah, okay, we might come back. So I want to make steel, I want to make iron, I want to make gold. I come across gold first for some reason. I want to make it because I need to make it. I scan through the list of reagents and I see that it is not available. I cannot make it. That's when I would jump back, go to the next one, say, I want to make steel. I can't make steel because I don't have the coal. I jump back. Okay, next up, iron. Hey, I've got enough iron. Let's make it. And then from there, we would jump back to the initial loop. So yes, I think it makes sense to be able to jump back. Yes. Okay, so now from this case, we're not going to modify the stack pointer. We're going to add an offset to it and use a temporary. So R15 is disregard, R14 is disregard. Okay. So move R15 is going to become stack pointer. Actually, what I can do is I can actually add stack pointer plus one. Yeah, because the stack pointer is still going to be there. Do I want to do this individually or what? Okay, so we need to, we're going to get into R14 at this point. The device, this is going to be from the cookbook at R15. And nothing uses 5 ingredients, so I can actually use a negative. Okay, so at this point we're going to have a, I'm assuming it's 62-bit number, and then the quantity. So quantity is going to be, what is it, extract into R13. We're going to stick with R13. If it gets confusing, we're gonna go ahead and do that. So extract, what is it? A extracts a bit field from A. So A is what we're extracting it from, which is R14. And you know what? Here's what I'm going to do. Because this makes more sense to me. Just because, let's see, that's 4 bytes, 8 bytes, 12, 16 bytes, right? Four bits, 8 bits. Four bits, 8 bits, 12, 16, 20, 24, 32. 40, 48. One more. So that's a 64-bit number. That's what I want to extract is the last two. I'm assuming I shouldn't have to put these zeros in here. I shouldn't have to. But R13 is currently quantity. And shift right arithmetically 2. And R12 should give me item. Hash. Ingredient. Hang on. Branch equals 0, R15, jump to request. I don't know. We're going to leave that blank for right now. That's going to jump over. And maybe I don't even put any labels in. If it gets too complicated, I might have to use branch relatives, which makes it more complicated, but anyway. So we now have the item hash and we have the quantity. What we want to do is we want to load batch. So R11, we're going all the way down to here, H silo. Name hash is going to be R12. Quantity, right? Yeah, quantity, and we'll go ahead and do sum. Okay, bam. So now I got the silo in there. Got the sum. So we have the quantity. Okay, set greater than or equal to R10. Yeah, I got so many temporary value variables here. How far are mine described out to 5? Okay, so R10. So R10 was set if the quantity in the silo is greater than or equal to the quantity requested for the recipe. Okay. If this is the case, where this is equal to 0, so there's not enough in silo, we are going to branch. So branch equals 0, R10.
Hunger caution.
If R10 is 0, there's not enough in the silo, we're just going to go ahead and jump on to the next item. So we're going to go return. We're going to return. Okay. This will be for branching after all of this. So in this case, we have that, we're set, we're good. We go to the next item. We jump up to make item. Okay, now post, let's see, order item. I know it's very confusing here with these stupid things. Okay, so we've iterated through, we are committing, we are making this item. So now what we're going to do here is we've got the item hash that we want. Let's go ahead and define a couple more here. So we're going to alias request name hash. Request name hash. Ingredient lists. Wait a minute. Item name hash. Yeah, we don't care about this. We don't care about this. No. Never mind. Because we already have it. We already have item name hash right there. So we know what to request. So we're going to set batch by name. Device hash is the memory chip. Memory chip. The name hash is... Oh, wait a minute. No, hang on. I did this. Set. Reference. Request. Setting. Item name hash. That's what we want. So we will load from ref shipping in R15. Shipping. Setting. Branch relative equals 0. R15 -1. That just boom. Actually, let's do that. Let's do this. We'll let it yield while we're waiting. At which case, load into R14. Now this is going to be memory chip name hash is going to be item name hash setting. Let's do average. R14 equal in silo start. So we're waiting for it to ship. Then once it's shipped, we're going to load batch again, R14H, not R14, we're going to do 13H memory. Item, name hash, setting, average. So R13 number in silo now. Set not equal. R12 If R13 and R14 are not equal, fully automating the furnace, it looks like. Add, of course. Yes. Yes, of course, add. Wow, I spell good. Can I? There we go. Yeah, whatever. Okay, like the code. Yep. So I'm trying to make this as robust as possible. So I'll do a quick walkthrough. So as it is, I've got a little. I've got one here that holds my recipes for the finished products, and that, and then I got the chef over here that's responsible for doing the cooking. So if I set a item hash into this memory chip, then this chip picks it up, ships everything that it needs out of here, stuffs it into whichever furnace it needs to be in, and does the process. And so far, since I've made some changes and used the digital chutes, the digital flip-flops rather, I have yet to have one of these fail on me. So I've had to do all sorts of silly things. I've got valves and everything, so I don't overflow into other furnaces and whatnot, but with all the limitations of my code, so far it's working. So now I just realized, what is that? Oh, that is the output. Okay, yeah, right. I got confused in my own ductwork here for a minute. So this is where the raw ores would spill out if they flowed through for whatever reason, which they don't do that anymore. And finished product comes here. Right now it just drops onto the floor, but I'm gonna store it into the silos on the roof here. And my furnaces are divided up by temperature. So there's, let's see, this one of these furnaces does solder and waspaloy because they're at the in the same temperature range. One I think literally does Hastaloy. And there's another one that does a couple others, and then this guy right here does the bulk of them. So they're all based on temperature. So 4 temperature ranges, and then I have them adjust the pressure accordingly. Obviously, waspaloy needs a lot of pressure. Solder doesn't need it so much. Stellite, astraloy, all those. So it adjusts pressure, but the temperatures are fixed. And I've got a little heat exchanger in the back that'll keep the whole thing set. Yep. And I make sure to use degassed ores so I don't have to worry about that particular problem. Now, there may come a time when I'm using steel that might be an issue. So, because I think steel will actually suck some heat out. But that's what the heat exchangers are for. So, most everything uses, I got an outside furnace that I had used in the past. I haven't used it recently other than when I goof up reagents and I need to fix them. But that's in a very sunny area, and it runs typically a lot hotter. So eventually I'll have a better method. But, yeah, so now I'm making sure that I fill my finished products silos now. Okay, so silo, so in this case R12 is equal to set not equal, so okay. Item count changed. So we're gonna do a yield, I feel like, right here. And branch relative. equals 0. So if R12 equals 0, then we want to wait, and we'll go up 1, 2, 3, -3. There we go. So now at this point, the number in the silo has changed, therefore we can set our request back to 0 so everything can shut off like it's supposed to, and we can move on to the next thing. And this code is a heck of a lot shorter than I was kind of anticipating it being. So we ordered the items, we're set, we're done. We need to go on to the next step. So I think in this case, we run back up to start, because I may have just changed, oops, jump back to start. Uh-huh. I think that might work. I think that might work. Assuming I got my shifting correct. Yep, assuming I got my shifting correct. So export. Export to what? We don't have a chip in there. Have an export to here. So theoretically, the waiter should go ahead and do everything. Now, that being said, let's go eat, drink, and be merry, and then let's go plumb the chutes, because that's my next concern. I like it. That is one of my goals someday as well. Fully automated from miner to printed product. Yeah, that's doable. On my Mars base, I had it set up so I had a vending machine out front that would make sure that I kept a certain amount of certain things in there. I didn't get very far with it, but I did have a working process, even though I didn't have anything plumbed. And over here, I have the method for actually generating items. So I got part of it done, and have tackled some of it. So, but yeah, that's what I really want to do as well. So I can always just run up and grab cables or chutes or have something. Because, yeah. And I was thinking about even doing small vending machines, just to make sure that they're semi-full. Birthday cake! Leftover birthday cake, I should say. Let's go ahead and take a shower as well. Wasn't that dirty because we haven't gone outside and done anything dirty. Check vending, or check traders. Oh, cycle the airlock. Interstellar excavators. That sounds like ores. That does not sound like fluids. But I'm going to be out there. I'm going to check it anyway. I have the chutes on me, so we should be good. Thought about that, or Larry stocking lockers for me. That would also work. Oh, still not exactly sure what is going on, but okay. I don't think that's how planes work in real life. And I know I've only got 2 hours in the air, but from my experiences. Okay, so this is where the finished products will come out. That was not what I wanted to do. Get back in there. Let's go ahead and turn that over. There we go. And 10. We'll do another 10. That actually kind of overshot, but do I want to? I don't know if I really want to fuss. I might have to fuss. That's no. guess I gotta do 3. Will these be at the same level? My luck, no, but... Ooh, that's actually darn tootin' close. Yeah, yeah. I think that driver needs a alcohol test, breathalyzer. Okay, we can go 5, 5, 3, and 1. 5, 3, and 1. And that's straight in. We have the emergency, something got in there that's not supposed to be in there, which I probably should actually have that wired up. And it's not important. It can go into this network. Okay. So first things first, let's just throw some junk through, if I can. You know what? I just realized I don't have a way to inject stuff. I don't have a way to inject stuff. Wow. Okay. We'll do that. You know what? We'll put a couple of windows in there so we can see them go through. And inlet. Need more chutes, of course. There we go. Okay. So. This should go through. Closer, it's getting closer. Yeah, there we go. Okay, good. That's what I was hoping for. I wanted to make sure that something gets in there that's not supposed to be in there. It goes through. Now, before I let that that one loose, I want to make some item that I can make multiple of, but probably copper. So I think I got a bunch of copper. And see that it actually ends up where it's supposed to. First try. And then I'll fire up that chip.
Pressure critical.
Holy crap.
Oxygen critical.
Took my helmet off before the door opened. That was smart. That was brilliant. Well, at least it was at vacuum. Would have been worse if it was in Venus atmosphere. So, first things first, let's get that last corner piece in line. So now, we are fully plumbed to go outside. Now, that does mean that, oh crap. I can make copper. Oh, silicon. That's what we're making. We're gonna make silicon. Manually. So, yeah, you get a demonstration of the system. So we're gonna take the hash, throw it here, and it's requesting what it needs for silicon. So it unloads everything. It gets stuck at this valve. That's why this buffer's here. And then it'll set the flip-flop here. So I found that some of these silos, they sometimes drop multiple per tick. So if you have one yield in there, or not even a yield, if it's just continuously loading the quantity and shutting it as soon as everything is dropped, you can sometimes get extra out of it. So that's why I've had to use the digital flip-flops, just to make sure that if there's an extra one, it gets dumped out and doesn't follow the mix. And kind of the same thing here with the furnaces as well. This is just like a secondary. If somehow something gets injected into the system, it's not supposed to be there, boom, it'll drop out. So in this case, We are just waiting to load. That was the last item in. Pressure, we're temperature, we're waiting for processing. Bam, auto eject. Nice. And now it's on its merry way. And we go ahead and do that. So before I turn that one on, we are going to verify that our silicon silo up top has the silicon ingot. Hey Breeze, 1 year. Congratulations. I appreciate everything you guys do. Jump. Okay, silicon should be on the bottom here. Oh, we can look here. Look. Invar? Wait, Invar? Oh, right. I put solder on the other side. Invar, electrum, constantan, silver, nickel, gold, iron, steel. Wait a minute. Hey, Mom. Hang on. Where is silicon? I don't have silicon down. Okay, that's awkward. That is awkward. Luckily, I can get away with that with this. Because that's just the memory chip. Yeah, it's a good thing I didn't let that. Silicon, 1. There we go. Silicon would be down here. Silicon, 1. There we go. We have 500 silicon ready and able. So that's okay. So that's 5, 4, 4, 3. 5, 4, 4, 3, or 4, 4, 4, 4, 16. Okay, there we go. I got the correct number down now. Got the correct number down. No, that's unfortunate, but fortunate. I happened to pick the one that I was missing. That's what kind of odds are that? Those are definitely not my normal odds. Okay, so now I say we go ahead and send that waiter to work and see what trouble he gets into. Planned, yeah. I wish. That would have been great. That's a awesome moment. So here we go. I'm expecting yellow lights. 3. Okay. So that's one of our... Is it? Actually. You know what's funny about that? I can't tell if it's just not reading that or... I mean, it very well could be. We'll just go ahead and grab that and edit. And that was correct. Reference ID. Structure circuit compact, because that is a compact, isn't it? Yeah, it's definitely compact. Okay, so let's pull this open. Export. Try it again. Went to 4, so it's actually supposed to be cycling through. However, I don't see the green. Well, that's not writing any stack to this. Oh, that's green, so I don't know. Okay, it should be able to, oh, it's not going to make any silicon, but it certainly could make nickel. It certainly could make, Could make steel. Could make copper. Could make gold. So it's got four things that it would want to make. All right. Okay. Time for debug. Time for debug. All right. Do we at this point set db setting is going to be the stack pointer. Ooh, new activity. Hey, thanks for the follow there, Busted Knuckles. I appreciate it very much. Those little sound effects are very nice, and I think those are built into OBS, so they don't necessarily happen or go across the stream. So that's what I've been trying to do. Yeah, what am I doing here? This move 0 ice next phase. Oh, geez, dummy! I just yeah. Okay, so I can see a problem here. So we jump to next phase. Except this yeah, right there. Next phase loop. Bam, right there. Set. Yeah. There we go. There we go. We've got it. Now in this case we can this is set db setting R15. So we're doing stack pointers. Okay. So there we go. There's the endless request. Bam. Okay, 40, 50, 60, 70, 80, 90, 100, 10, 20, and 30. So this is going through scanning all the items. Now it's going to be going through and checking the 50. Oh, that's kind of weird. Hang on. Okay, so first phase goes through, it's reading the quantity, gets to 170, should loop around. Now it's, why is it saying 1? Plus 1. Am I accidentally adding... Okay, so we're jumping through... here. Go to next phase. 10. Now, this right here, R15. Okay, that makes sense. So this is the make item. Oh, hang on. Hang on. Jump back. Oh, ho, 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 ho. Right. Yeah, it should loop back through. R15. Add 15. Oh, wait a minute. Hang on. I'm missing something here. I am missing something. R15. Branch equal to 0. This is... Hang on. That should be there. That, okay, alright. Alright, alright, alright. Let's try this again. Let's try it again. Okay, now it'll go all the way through. back up a little bit so we can see the item if it goes here. Okay, so this should jump to 1, 11, 21, 31, 41, 50. I don't know why it goes to 50. That's a little weird. Now, I can tell you that's not right, because there's definitely at least one thing in there that can be made. Okay. Alright. So we're getting to this point. We're going to get into R14 from the cookbook at address R15, which is this stack pointer. Oh, you know what? There we go. Okay. One more thing. Eventually, we'll get there. Export. Try it again. Okay, just switch over. We're going to do this again. It's definitely the challenge when you get into the stack is remember what all your pointers are and everything. So this should 1, 11, 21, 31, 41... 50 is still weird. Why it just jumps to 50 and not +1. However, I will say that, again, there's stuff that could be made. Why aren't you doing it? I got enough. I can break these up a little bit. So, make item. R15 becomes stack pointer +1. We set that. Now we get R14. So we branch equal to 0 to order item. And we know that never happens. So we branch equal to 0, order item. We're going to check it. feel like something's not happening right. I feel like it's going through the phase. Wait a minute. Let's confirm the behavior. So it runs through one time. I have a feeling that 50 is like the first one that maybe it actually can make. Which, that might be gold, might be copper, or I forget what order my recipes are in. So it runs through this phase, seems to be okay. We don't necessarily know what the number of items ends up being. My assumption it's 0. Go here, we move the stack pointer to 0 to start the next phase. We get that. Branch equals 0, go back to start. So we'll go back here. Otherwise, we load memory, make this item. Branch AL. Alright, and we overwrite everything in here, so that's not a big deal. We add. We come in here, R15 becomes stack pointer +1, which is our first ingredient. We read this and so we get it. We get it. We get the item into R14 from address R15, which is that. We AND it together. This is quantity. Maybe I'll just do AND FF. We'll shift right 2 bits. That'll get us our item hash. This is where debugging comes in handy in different monitors and stuff. And I might end up doing that. Set greater than. You're loading from the silo, right? Quantity. Okay. I feel like there's something in here, so I might have to bring out some debugging. Debugging consoles and stuff. Okay, so we are... What are we going to do? We're going to name this... item name. Yeah, sure, we'll do item name. Okay, we'll do another memory chip and monitor soon enough. But let's do this. Luckily, we have enough space in the chip to actually do this. Make light art. Should I? Set device hash H memory name hash is item name. Settings R14. Next phase. Do this. So we know we're gonna get into. Go to make the item. R15, however, is not the name hash. This is... We're doing R15. Hang on. Item name hash. What am I doing? Item name hash. This is what we're trying to make. This is what we're trying to make. This is what we're trying to make. And we already would know what this is. So one more chip, and then I can put what ingredient we're looking up. So, okay. So silicon, it's looking a little weird. Right, because silicon... Yes, okay. And silicon looks like that because we aren't going to make silicon because it is beyond the maximum. Okay. Alright, let's go get some more. Let's see, we got a monitor. We got name hashes. So... Hash display, console. I don't have any memory. That I've got to make. We're almost there. It's just debugging at this point. Let's just go ahead and make 10 of those. I think that needs iron and... Oh, it's got everything it needs. Gold and copper. Didn't need the iron. Okay. That's fine. That is fine. get rid of that radar because they warning has expired. Whoops. I pushed the button. Okay, I'll just take this with me and put the rest up on the shelf when I'm done. So now we can memory chip. And since I've already got I can drop the memory chip there, console. Hash display. Okay. All right. Ingredient. Okay. Ingredient. That's actually terrible, but we're gonna do it. We're gonna do it anyway. Oh, right, I forgot. Okay, we're looking for ingredient. Okay. No, wrong button. Pull this up. We're going to go up to the very tippy top, and we're going to do this. It's a little goofy. We're going to do that. Okay. Now when we're in the making an item loop, get through here. Quantity and item. Set this to R12. Now if this doesn't come out right, which that's what I'm wondering if that's going to be the case. So we're going to cycle through first. So phase 1. Now we go to phase 2. Okay, so what I'm getting out of there is not correct. At all. At all. Okay. So at least now we know where the fault is. So it is literally in my decoding of the item here. So R14 is supposed to be so the item hash is there, so it's not shift right. Arithmetic. Oh, that's bits, isn't it? That's bits, not bytes. That's bits, not bytes. Somebody is a moron. It's bits, not bytes. There, we'll see. We'll see. Be so nice if this works. Okay, cycle through. There we go. There we go. There we go. We're crusting copper. Good. We can make it. Oh, that's so awesome. It's dumping it. Yes. Good. Okay. We're making it. Going through, dumping everything in. Right. Processing. Okay, everything has made it in. Sweet. So this is what we're trying to make. That is what we are making. That is the ingredient that we were checking against. We're going to see this dump. eventually. So first thing that's going to happen is the output is going to kick off. Then the input when it's at pressure. I guess not necessarily the output, but one of these will turn off, then both of them turn up. Yeah, one of them off. Pressure matched, or temperature matched. Just waiting for things to process. Boom, gone. Okay, we're shipping it. So we are waiting for the silo to receive it up top, which may take a while because there's a lot there. And it's zeroed out, and it's doing it again. It's starting the process again. Ooh, buddy. Ooh, buddy, we got it. Now I just got to make sure that I've got all the ingredients around, but we've got it. Should make gold. Making gold. Oh, that's so awesome. It's working. It's working. It lives. It lives. Oh. And it may actually make a steel as well. Because I think, what's this? This is nickel. It could make a nickel as well. So steel and nickel. Steel and nickel are the next thing it's going to make. Steel and nickel. Now, hopefully this doesn't botch anything. Let's see. Worst case scenario, something's botched. I get reagent mix. It's going to come out of the import bins at the base, or at the back. So, cool. Oh, I am so happy that worked out. It works. It works. Okay. Temperature matched, pressure matched. Processing. Dump it. Okay. They're shipping gold. We are waiting for the next bit. We are waiting. We are waiting. So what do I say? Steel and nickel. So it'll make nickel, and then it might make the steel. Okay. Nickel. Yep, we are making nickel. Awesome. I am so thrilled. So thrilled. This is... I planned for this for so long, and it's now finally a real thing. So at this point now, it's just a matter of gathering ores, and that to some extent can be automated at some point. I do have the mining outpost, which reminds me I need to make some backpacks. All right, thanks for stopping in. I appreciate it, and yeah, this is I'm so happy. Other than a idiot bit shifting 2 bits instead of 8 bits, that code was pretty solid. So beautiful. Beautiful. Pressure matched, temperature matched. Temperature match, pressure match, actually. Processing, dump. Good. Now, steel will be the last thing that it can make, because I don't have the ingredients for anything else. But this way, it will make 1 of everything, then 2 of everything, then 3 of everything, and it just goes up that way. Up until... yeah, I wonder. Okay, so now, steel. Steel. Oh. Interesting. It wants to make iron, it wants to make silver, it wants to make solder, electrum, steel. A little confused, or... oh, maybe it was cycle. Oh, yeah. The first cycle. That's right. Yep. Duh. Duh. Because it's got to run through once. Beautiful. Oh. So after this, it should basically cycle endlessly because it's not going to have anything to make. But we can change that. We could change that. Keep going, keep going, keep going. Well, I know at this point it's going to work. Now. I just had a thought. This could be a problem. In the case of steel, because I have the flip-flop, this might actually... Yeah. That's a good point. Because of the flip-flop that I have upstairs, there's a possibility that it might not ever make it into the silo up there. So that means I need to double my steel recipe. So we made it. And I'm going to stand over here so I can hear the steel silo. And see if this receives it or not. Hopefully it goes upstairs. Oh, it worked. It worked. It went through. It went through. So it worked in that case, but I still need to double the recipe. Just to make sure that it doesn't get stuck on that. Yep, so it wants to make iron. It wants to make silver. Wants to make solder, wants to make electrum, it wants to make constantan, wants to make all of these. It's going through, it doesn't have enough. Cycles through. Brilliant. Brilliant, brilliant, brilliant. Oh. Awesome. I'm so happy. So happy. So now we just need to provide materials for it. Good. Good, 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 good. So... Nice. Now, mining backpacks. Boxes, mining backpacks. Let's see. Let's go ahead and drop some of the stuff off. Logic memory. We're gonna drop off some of these sheets, frames. That's fine. Plastic sheets. We're just going to pack these with us. We're going to leave the padded walls here. I don't need the chutes at the moment. So I need to have... I got 4 up there. Backpacks. Hard mining backpacks. And let's go ahead and make 5 of those. And those come out of the tool printer. And it, of course, wants steel and Invar. Invar's easy. Steel is also pretty easy. I totally whiffed that. Hard mining backpack, right? Hard mining backpack. Okay, cool. And we'll take these out to the ball game. Let's go ahead and make a large box. This bug still bugs me. Okay. Large box. Look, there's a whole bunch of stuff I can make now. I'm gonna go ahead and make 2 of them. So at some point, I want to put a loader into these, or onto these. Because I just feel that that would be phenomenal. Okay. I have one. Yeah, I think that's fair. So 4. Okay. drop these in the airlock or by the airlock so we know that we need to make a trip out there at some point. Orbit or Outfitters, Stellar Stone Supply, Space Spanners, Interstellar Excavators, which I still have on the platform apparently. I didn't dismiss them. Didn't look at them. That's right, I didn't look at them. I just literally threw that there and picked it up. Phenomenal. So, yeah, very good. I think that's about 20 minutes potentially left. Do I want to end it on a super high note like that? I might. That's thrilling. We could discuss the next steps, though. So, okay, so, yeah, so we got that auto order system going. The next thing I want to do is have these machines, like when I go to make something, i.e. the large satellite dish, I want it to set a request, much like the waiter sets a request for the make an ingot. So have the production machine set a request for an item to have it shipped. Now that would set some valves for it and get it there. So we ship one ingot to the machine, wait for it to get to the machine, then we clear it, go to the next thing that needs a request. So there's the caveat to that is I have to have the ores to have the item up above to ship. Otherwise, it could basically kind of clog up the request line. So that's really the only caveat. But, I mean, we're almost there. We are almost there. And that'll be probably very similar to that. Will be two or three chips, depending on where the ordering system is. And it will have, those three chips will be a memory chips that will be buffers. So it might not, maybe two chips. So this will set a requested item, and then the other side will say, I see your request, now I'm shipping it, and put it into the shipping label. This is going to see the shipping label, and whatever chip on this side is controlling it, you know, setting the request, will also set the chute valves and everything on this side. So it'll see that it's shipping, it will wait for it to arrive, and then it'll clear the requested, and this side will say, okay, I see that you have received it, I'm going to cancel the shipping, the tracking number, so to speak. So I think that's the way to go. And then of course I'll have a way to junction in stuff. I can manually load it, but I think that's what it is. So it's going to have, yep, there will be an IC on this side making the request and controlling that, and then there will be an IC on the production silo side saying that I want, or yeah, that to ship and receive. So that'll work. You're still cranking. Yeah, we are catching up on the temperature thing though. So I am so happy that thing worked. It's a long awaited dream. Let's go check on Larry real quick, make sure he's not crashed or anything silly. He should not have a problem. Temperature's nice and cool in here. That's cool. I would take it down a little bit further, but I'm got the greenhouse that I'm worrying about. So, Larry, how you doing? Larry's looking happy. What? Why did that say? Did I mouse over the wrong thing? And yeah, so he's definitely overwhelmed. He's probably got like 10 too many stations. And the stuff down here obviously is not going to work. So, I mean, most plants are going to be at least half of this. So, I think very easily a non-switchgrass Larry could actually tackle 2 lanes of this. No problem. Of course, we got to look. How are we doing here? Up to 24 liters of water. 62 liters of alcohol on this side. We still need more, another centrifuge because our biomass is getting out of control. We could direct burn it, or direct it to methane. But I like the idea of having a cooling system based on the alcohol, so the excess alcohol will get converted to methane if the temperature in the room gets too high. So this is also a thermal tank too, so as the ACs cool it down, it's actually cooling this down. How's our other stuff going? You're doing okay. 124 liters of drinkable water. That's cool. I really need to do something with water too. Good. Yeah, I'm happy with how things have progressed today. That's just beautiful. And yeah, you're high pressure because you're actually Is it because you're shut off or what? You're getting sucked in. You're active. I mean, we can turn that off for a little bit. Pressure efficiency should kind of drop out here real quick. Maybe not. Whatever. Whee! Good. I think I'm going to call it there, though. That was a very big success. I'm happy with it. And from here, it's kind of little things like running out to the outpost, refilling the backpacks and all that fun stuff. And that might be a good one to... Actually, I should probably take the chutes with me. So let me, real quick, I want to grab that chutes backpack just to make sure that I don't forget when I go out there. Because I very well may want to put in a loader-unloader kind of thing. So I'm going to drop that right there on top of it. Yeah. Beautiful. Beautiful. We will eat, we will drink, and we will be merry. Get a shower. Excellent, excellent, excellent. I am so happy with that. Not if anybody could tell, or, I'm sure. I didn't even check. Yep, there we go. That's beautiful in every single way. Mining belt. Head, shoulders, knees and toes. There we go. So, yeah, this greenhouse is almost to the point where it's kind of out of date. Definitely making a lot of oxygen and all that. Beautiful. Actually, how are we doing here? How are we doing? We still have 12 liters. Temperatures looking fine. I don't know if this disappears at all or something. I guess I gotta think about, but maybe having an extra liquid nitrogen at some point would be good. But doom will regenerate deceased patients, will heal damaged patients. Cool. So anyway, that's a very, very happy note to leave off on. So I will leave her there for the night. So I would like to thank everybody for watching, and we will catch you next time.